Hi, and welcome students to our last section of Chapter 5. Alright, this is our Chapter 5 section, and this says 5.1, but that is not true. This is 5.2, and these are the topics that we're going to explore today. It's all about percentages. We have where the word percent comes from, meaning out of 100, and we love to look at percents that they feel comfortable to us, and we're happy understanding things out of 100. If we look at 12 over 16 and we wanted to relate that as a percentage, here is one way to do that. We could also do, and we usually write this as 12 over 16 times 100, and that will get us our percentage. Notice they're going to do this a lot in this textbook, but note if I were to multiply both sides by 100, I would get the exact same thing that we've known to come and love. So if I write it sometimes like this and sometimes as the textbook is, just note that we are indeed talking about exactly the same thing. There's no difference. At 12 over 16, that is a fraction because it has a 4 in each, reduces to 3 over 4, so note that that is our 75%. Just a few different examples of using percent and where you would use percent in your everyday life. Money, news stories, weather reports, and then they have grass seed, germination rate is 80%. All of those things, just normal everyday examples of using percentages. Looking at our ratio or our fraction here, 8 out of 12. So if I make 8 out of 12, if I want to know what percentage that is, I would do 8 divided by 12, and I would get this is 67%. If I wanted to do 15 over 20 and figure out what that percent is, I do 15 divided by 20, and I would get that that is 75%. So who would I want up shooting? Probably Rachel, because she does a free throw rate of 75%, and Becky only makes 67%. Of course, it would depend on their attitudes too. Here is just a manipulative or a graphic talking about what 67% looks like. You notice if I were to draw a straight line down, you could see it more easily and know that these are the shots that are made, so I could look at that percentage happening. Next example, we are looking at 8% of this 7,968 students. They want to know, estimate, so I'd probably do 10% out of 8,000, and so that would be, remember that of means times when looking at math, so it would be 0.10 times 8,000. So this would be about, moving my decimal point, 800. So it would be about 800 students. And looking at that as a visual, here they have what this would look like as a visual. If I wanted to know the exact, I would do 0.08 times 7968, and that would be the exact number. If we're going to look at buying a house and this monthly payment can't be more than 28% of my gross monthly income, what does that need to be so that I can buy this house? Now, this is true, this isn't an easy question, but if I kind of reword it as 28% of some number, I don't know what it is, needs to be about 800. So I could write it as point of meaning times 0.28 of, or times some number, we'll just call him x, equals 800. That makes it much easier to solve if I can rewrite it in some format using an of and the word is. And this would be 0.28 divided by 0.28, and my x would then be 800 divided by 0.28. This would be my gross monthly income needs to be at least $2,858, we'll say. We'll round up just to make them safe. So they probably need to make at least $2,900 in order for this to be a reasonable monthly house payment for them. Oh, and here's our visual, and they wrote it out in this format. Once again, looking at these in terms of writing them down as fractions or equivalent fractions, you could do that as well. So this is one for each of these different problems that we looked at. Percentages, we look at those as part divided by the whole times 100. Alright, so we have George is excited. Let me read this. Okay, so we've got 20% off our merchandise. It's regularly $260. There's two ways I could look at doing this. I could do $260 times the 20% to figure out it's how much off I have. And if I do that, I get 260 times 0.2, and that would be $52 off. And then in order to get the price, I would have to do $260 minus $52, and I would say that the sale price would then be $208. The other way I could look at doing this, and it's more straightforward if you would consider doing this instead of having the subtraction, I could say, well, if it's 20% off, that means that I will pay 80%. So I could do 260 times 80%, and if I do that, punching 260 times 0.8, I get magically $208. Imagine that. This way I don't have to do any subtraction. So that's kind of a fun way to approach these problems, where you don't look at what's off, you look at what you actually pay, because that's what you're really interested in anyway. And they tell me that percent change, percent error, percent, so you really have to pay attention to what they mean by percent increase or percent decrease whenever you are looking towards doing these problems. Oh my, this is a long one. Let's hold for a minute. Alright, so why would some people be upset about this if everyone across the board gets a $2 an hour raise? Well, those people that work harder would be a little disgruntled, because they might be thinking, well, you know, I worked my butt off and Bubba over there was sitting on his little butt, and I should get more of a raise than Bubba. Or you might say, well, I'm a manager and I make more money, so $2 an hour is just a pittance compared to what I really make. I should be getting more of an hour raise because I won't even notice $2 an hour. And then those full-time workers might be a little upset because they might think that the part-time workers don't need the $2 an hour raise. Well, just goes to show, you know, this has to do with percent increase. It also has to do with you can't make everybody happy anyway. Okay, so how much money did, oops, pen. Oh, do the pen. Okay, so how much money did the bookstore pay for the textbook? So they generally sell their books for 20 to 25% more. Let's say you paid $95 for a textbook. So we know that what happened is they paid something for a textbook. Let's call this X. X is what they paid. And what you're going to pay is what they paid plus 25%. So you could say that that is 1.25 times what they paid is $95. Now that's a really nice way to go about it instead of doing the addition like I did on that other problem where I kind of cheated around not having to subtract. I'm doing the same thing here because I'm saying that you're paying 125% of what they paid, and that is $95. And dividing both sides by 1.25 in my little workaround, I would then get, let's see, 95 divided by 1.25. That means that they paid $76. And you could have worked it a different way. You could have said 100%, or you could have said 1, probably what you would have said, 1 plus 0.25x equals $95. These problems are a little tricky because you're adding or subtracting in that, and here you pay 1x, sorry about that, 1x plus the 0.25, and then you end up with the 1.25 or 125%. Percents less than 1 or greater than 100 tend to get confusing for people, students, everyone really in general. And if you encounter percent greater than 100%, now you're not going to encounter that like in probability. So, because if I said that the chance of snow was 100%, means it's going to snow. You can't really say that it's 200% because 100% means it's going to snow. But if I'm going to pay 200%, then that means you're just going to pay double. You know, if I said I was going to pay 200% of whatever, or anything less than 100 just means that it's really small. In percents, as in interest when you borrow money, these things are not really intuitive. Our brain tends to think linearly, so when we go to buy a car or a house or student loans and our interest is compounded, it really boggles the mind how much interest we end up paying. So here, for example, here is a house, $225,000 house. You make a down payment, means you borrow $200,000. If you have well, they don't tell you what your interest rate is, but you have some sort of interest rate, and that interest is compounded. If I look at making this payment of $11.51 for 30 years, which is 12 times 30 years, so because you make monthly payments, you end up paying $459,000 for the house, meaning that you paid a ton of interest. And it is counterintuitive. It is because it is a multiplier instead of things that are added. We tend to think in our brains as adding, but these loans and interest, just know as you're computing them, your interest earns interest, whether that means you're putting in or you're borrowing, and over time that adds up a great deal. And here we have just a general problem with an interest rate. They're starting you off saying that you're going to borrow $2,000 and you're going to pay 6%. So that's $120. After that 1 year, no compounding of interest, just $120 just one time. But if the interest is compounded, and let's say you did it for a year, but your interest was compounded every 6 months, well, that means your interest earns interest, and here they did that computation, so you'd owe an extra $1.80, which doesn't seem like much, but that's just if you did it every 6 months, if you compounded it every 6 months, well, we don't typically compound interest when we do loans every 6 months. We do it daily. So it does add up over a long period of time. Oh, and that's the end. Oh my goodness. That is the end of Chapter 5. If you have any questions, be sure and email me. It's been a great class.